Sorry I couldn't be there today. I had something come up. So you got this assignment in MyOpenMath. Shouldn't be too bad. Select all that apply to x-intercepts. They are called roots. They are written as x0. They are called a solution. They're not written as 0y. That'd be a y-intercept, right? Y-intercept. Setting x to 0, that's y. It's where the graph crosses the x-axis. We solve for setting y to 0. And they're also called zeros. Key. There we go. All right, so some of these I'm just going to tell you the answers to. All right, a y-intercept would be referred to as 0y. It's solved by setting x to 0. It's where the graph crosses the y-axis. And if you don't believe me, there's the key. All right, moving forward. What are the solutions to these things? All right. So this is where we use that zero product property. I wish I had like overlay and I could write on this, but I don't think I do. I should probably Google that. Anyways, I'm just going to snipe it.
Because his time is top 10 on the time.
I'm not at school, so I don't have my big board to write on. But we're going to use that zero product property, and we're going to set each factor equal to 0. So 5x plus a 9 is a 0. Or, if I can type, 5x minus a 3 is a 0. Now, 5x plus 9 is 0. 5x is negative 9. Divide through by 5, and x is negative 9/5. That's one of the solutions. And on MyOpenMath, you just do a comma here. That's the way they used to do it. Shift that 3 over, divide by 5, x is 3/5. So, just to make sure you guys agree with that, bam, they just use a comma to separate. Now, the coordinates of the x-intercept, well, that's going to be at negative 9/5, and y is 0, because we had it set equal to 0. And they want probably a comma. 3/5, comma, 0. And something's wrong there. There we go, comma 0. Maybe I'll get it. Bam. See, it ain't too hard. All right, given the function, answer the following questions. No, buddy, let me get this video done so we don't waste the kids' time. Okay? This is for my students at school, Emmett. And they don't want to watch any more of this than they have to, I promise you. All right, so I haven't done this with y'all yet, but it's not a leap of faith as to what you have to do. I believe if you see something that's squared, you're going to write it twice. And we're finding the solutions, by the way. So and actually, we don't have to do that. 0 equals 9 times x minus 12, quantity squared, minus 135. What we're going to do is we're going to add that 135 to both sides. What we're trying to do is we're trying to isolate this square. All right. So I added 135 to both sides. Then I'm going to divide by 9. And 9 enters 135 15 times. I was really expecting some that would work out better. But this one's kind of an ugly one. So it's going to have ugly answers. The opposite of squaring is square rooting. So it's going to be plus or minus. And I don't have a good square root symbol. Plus or minus the square root of 15 equal to x minus 12. I'm going to add 12 to both sides, 12 plus or minus the squirt of 15. So those are my solutions. I'll go type them into MyOpenMath. We have a 12 plus a square root of 15 comma, and 12 minus the square root of 15. I'm pretty tired, so let me make sure that's right. And let's get it. Look, I was right. So the x-intercepts is going to be the same thing, but in order of pair. 12 plus the square root of 15, comma, 0, because y is 0, and 12 minus the square root of 15, comma, 0. Whoops. There you go. If you don't believe me, bam, key. All right, now how are we going to do this one? I think it'll factor. What is it, Mason? That milk tastes like vanilla ice cream? That's pretty good milk. So to do this one, you had a choice here. You can either do factoring or the quadratic formula. It's really your choice. I think I'm just going to do QF on it because I can't guarantee you what you get. So if you remember the song here, it's x equals negative b plus or minus square root b squared minus 4ac. Boy, this is bad. I'm writing with my finger. All over 2a on a laptop. It'd be cool if I had a stylus that would work. Yeah, that doesn't work. All right, so we'll plug in and we'll go with it. X equals, opposite of a negative 4 is a positive 4, plus or minus square root, parentheses, negative 4 squared, because b is negative 4, minus 4 times a, which is 4, times c, which is 2, all over 2a, twice a 4. Now, what's in that radical? In that radical is 16 minus 32. Huh. This is 4 plus or minus the square root of 16 minus 32. Both pieces over 8. Now, this is going to be the root of negative 16, which is not real. All right. So this example is a DNE, does not exist. Oh, they did imaginaries. Okay, I'm going to pull this question. I was not expecting that. Question 4 needs to be removed. So you may skip number 4. I need to play with that. What do we have here? We've got kind of some things we did up above, where we do some things. I want to make sure this one works out. Good, it does. But I'll pull the imaginary concepts. So let's jump down. Let's look at this one right here. It's similar to one we did before. We're supposed to find the x-intercepts, and we're supposed to plot the points. Won't be too hard. Now, your x-intercepts happen when you are set equal to a 0. So 0 equals negative x plus 1 quantity squared plus a 9. We're going to shift that 9 to the left. We're going to divide out the negativity. What is it, Mason Lee? I'm sorry. Can I do anything for you? All right, now the square root of 9 is going to be plus or minus 3. And that's equal to x plus 1 because I counteract the squaring by square rooting. So I'm going to take away 1 from both sides. What is it, Mason? Yes, it'll go away. Now, negative 1 take away 3 is negative 4. And negative 1, sorry, I did that wrong. Negative 1 take away a negative 3 is 2. Or negative 1, okay, Emma, I need some time, plus a negative 3 is going to be negative 4. And my solutions here are going to be 2 or negative 4. See? And they actually want it to be done as coordinates. Y-intercept. That's something you haven't done since Algebra 1. We let x equal a 0. So this is going to be y equals now negative 0 plus 1 quantity squared plus 9. Now, if we square a 1, we get a 1. Don't forget there's a negative symbol out front. You can hear Emmett playing the repeater game over there. And negative 1 plus 9 is 8. They're going to want this as a coordinate. It's going to be an ordered pair. It's going to be 0, 8. Don't you wish you guys could hit the key on this while you're working on it? And they just want us to plot these points. So we have a point at 2, 0, a point at negative 4, 0, and we have a y-intercept at 0, 8. What this lesson is not doing is the vertex. Anyways, there we go. For some reason, number 6, I've already pulled up the key. And a 6-year-old is playing the repeater game.
6-year-old is playing the repeater game.
Now, when I look at this equation right here, I see that I can pull a 2 from everything. If I pull a 2, I'll have x squared plus 2x. Emma, that's enough, please. Minus a 3. Since I want my x-intercepts, I set it equal to 0. I'm going to keep factoring. Factors of negative 3 that add to 2 are positive 3 and negative 1. Now, by the ZPP, the zero product property, x plus 3 is 0, or x minus 1 is 0. Emmett, I hope this is not recording you. So x is negative 3, or x is a 1. And you can see here what they've done. How did they find the y-intercept? We let x equal 0. This is written in standard form. This will be the y-intercept. You can see it. But if you don't see it, which not everybody does, Emmett, would you like a spanking? Would you like YouTube to hear you getting spanked? Didn't think so. Plug in a 0, and you get y is negative 6. And that's where this answer came from. All right, what's next on here? Is there anything new? 7's just the same, except 7's already factored for you, isn't it? Like, how hard is that? 9, 0, and then negative 3, 0. Perfect. Now, the coordinate of the y-intercept, you let that x be 0. That makes this negative 9. You let that x be 0. This makes 3. That's negative 27. So x was 0, negative 27 for y. And then you plot your points like they tell you to. Yeah. This one's kind of interesting. It's worth doing. Notice it only had one x-intercept. I'm going to factor is what I'm going to do on this one. So I'm going to pull the negative 2. I'm going to set it equal to 0. I'm going to pull the negative 2. That's going to leave me with x squared plus 6x minus 9. All right, cool. Going to factor x plus squared plus 6x minus 9. Sorry, I pulled the negative, didn't I? Minus 6x plus 9. Now it factors. A negative 3 and a negative 3 add to negative 6, and negative 3 times negative 3 is 9. What we have here is we have x equals 3 And it happened twice. It's a repeated solution. So we're touching the vertex. We may or may not have talked about that yesterday in your class. The y-intercept, you let that x be a 0, you let that x be a 0, and you're left with negative 18. So you should see 0, negative 18. All right. We did not do these as much as I had wanted to. So I'm going to show you how to cheat on this. We're going to take this equation they give us, and I'm going to put it straight in Desmos if I can select it. I can't select it. All right. Negative 4.9 t squared plus 256t plus 157. You actually get to use Desmos on your, oh, I'm in Desmos. I don't need to be using t's. I need to be using x's. There we go. What was the problem? NASA launches a rocket. All right. Its height in meters above sea level is negative 4.9 t squared plus 256t plus 157. Assuming the rocket will splash, Emmett, that's enough. Assuming the rocket will splash down the ocean, at what time does splashdown occur? So I'm going to zoom out. And there's my answer. Because the rocket go up and the rocket go down. 52.851. They want it to the third decimal place. Notice that. What was the initial height of the rocket before it was launched? That's this number right here, 157. It's going to be up here somewhere. If I zoom in, maybe you can see it. But that's going to be the last Mason Lee right here. Yeah, Desmos is going to struggle with that. Really hard to get your cursor on it. It's this Mason. Stop. You know I'm recording. It's just the last number, kids. Because if you let time be 0, these two pieces are gone. And there you go. I'm recording. You said you'd be quiet, remember? It's just like at church, Mason. Be quiet. Stop. You're making this longer on my students. All right. So if you can do 9, you can do 10 the same way. Initial height, like that's the 60 at the end. Like that's easy, 60. How many seconds does it take till the ball hits the ground? Take your equation, put it in Desmos. We'll have to use x's though. Negative 16x to the second plus 68x plus 60. I'll have to get in closer. Looks to me like it's 5 seconds. There it is. But it's 5. All right, last one. Last couple of ones. These are just factoring practices. So there's interval notation. That stuff you already know. Boys, stop. Sorry about my kids. They're being rowdy. Anyways, there's your MyOpenMath assignment.